Welcome to programming session on pointers. This one is important. Programming session on pointers. Let us start the programming. We'll try to go slow. Hash include stdio.h main. So let us declare two things. Integer v. V is a variable, ordinary variable, which is capable of storing integer, and then say integer star pv. So this is the way of declaring the pointer, star pv. That means pv here is a pointer. pv here is a pointer. Remember, it can be just x also. Only thing is, for convenience, we are using pv. Okay, we have declared an ordinary variable, a pointer variable, an ordinary variable and pointer variable. Let us try to find the size of it. Let me try it. The size of v is I think percentage %d or percentage %u is used. Let me check. It varies from compiler to compiler. That is the problem. Size of v. Let me check it. Let me save it. So ex sum16.c. Save it. Build it. Compilation failed. Why compilation failed? Warning, and then what is the error? Expected error expected semicolon before this one. Let me check. Printf semicolon before this. So here at this point, size of v, okay, double quotes are there. Build, okay, execute. The size of v is 4. The size of v is 4. Size of v is 4. You can see size of v is 4. That means integer occupies 4 bytes. It's quite obvious. Let me try to find out the size of this pointer also. Size of pointer also. Let me try to do it. Size of pointer also. Size of pointer is say percentage %d /n percentage %d /n. My voice may go down because I'm not teaching, I'm doing the programming. In between, voice may go down. I will try to maintain the same pitch, but sometimes it happens. So size of pointer here is 8 bytes. Size of pointer is 8 bytes. So it should be independent of the data type. Let me again declare another variable, say float, say fe. Let me call it as fe, float variable, and let me again do the same. So float fv, say another one, float star some fv 1 or pfe. Okay, now let me try to print both fe size of fe and size of pfe. Let me check. So here you can see whether the pointer is pointing to integer or float, whatever may be, the size of pointer is always 8. This may vary. Here in this system this is not varying because it is using 4 bytes for both integer and float. For both integer and float it is using 4 bytes only. It is using 4 bytes only, but you can see here the size of pointer is 8. Let us try with other thing. Okay, we'll leave it here. Okay, the point to be noticed here is the size of the pointer is same or it is independent of the data type. That means whether it points to integer, whether it points to float. In fact, it may point to an array which is a collection of values, but size of pointer is same. But these sizes may vary. Okay, these sizes may vary. It depends. Okay, that is regarding the size. Okay, let us consider something else. If you want, I can place it in comments. So we have, say, v and integer star pv. So the first program that we generally consider is pv equal to unpv. V equal to some, say, some 10. V equal to some 10. Okay. Now we discussed how do you print the value of v. Printf value of v is %d. Value of star pv is %d. So we are printing v and star pv actually. Star pv. What are the values that are printed? V is 10. PV is made to point to V. PV is made to point to V, and V contains 10. So first value that will be printed is 10. V is 10. Now what is star PV? So star PV, because PV is pointing to V. Star PV is also 10. Let us check. So here you can see both are 10. Now what is the address of V? Printf address of V is %d. Okay, the address of PV is %d. So how do you obtain the address of V? That is unv. The address of PV, the address of PV. Let us first try PV. What is printed? If you just write PV, what is printed? Is it the address? Is it the address of PV? Address of PV. So I will write ampersand first. Let us modify it later. So the address of V is something else is printed. Something else is printed actually. Something else is printed. So these are different addresses. Negative value because I think the format specifiers. The format specifier is something else. Probably in this one, this is the problem we have. I think we have to use %u. Let me check. Let me check once. So it varies from system to system. So here you can see, probably you have to use %u. Okay, the addresses are printed. The addresses are printed. The addresses are printed. Okay. The address of V is something, some value. The address of PV is some value. There need not be any relation between these two values, but these are the addresses. These are the addresses. You can see the whole number. You can see the whole number. Okay. So if you print actually PV, let us check what happens. And V PV, and V PV, and V PV. If you observe carefully, what is it? If you observe carefully, so this is 532, this is also 532. Why? I have not changed this one, but I have changed what is being printed. So both are same. Both are same. What does it mean? Can I write here? Let me check. Let me erase it. Let me increase the length actually. I will increase the length because this may not fit. So what is present here is the address of V. What is the address of V? This one. 1837 1837 1837 104532 104532. Okay, this is present. What is that actually? This is the address. This is PV. Okay, this is PV. This is PV. This is V. This is V. This is V. So the address is here. Now what is this location? What is this location actually? This location is same as this one. This is 1837 104532 104532. So this is the address. So the address is stored here. Where is the value? Value is here 10. So this is how it works. This is how it works. If you want to retrieve this value, directly you can print the value of V. Indirectly using pointer means print star PV. Star PV will get the same value. Now this is the address. This is the address of V. Where it is stored? It is stored here. It is stored here. Again, this will have some address. We have seen that address also. something else. If I rerun again, I cannot draw the diagram again. So this will have some address. Say some 185, 1837, 104, 104. Instead of 532, say some 548, something like that. This will have address. This will have its own address. Okay. If you print the value of PV, this will be printed. Now I hope you understood. So the address of V is stored here. You can neglect this one. The address of V is stored here. If you want to retrieve the value, use V or star PV. If you want the address of this one, use unv or just PV. Okay, that's how it works. I hope you understood now. If you want, I can the address of PV and PV, value of PV. Let me try it. Value of PV. Let me try it. Now what are printed? To change it, actually forgot to do the modification. I have to change these statements. So the address of V is that one. Okay. The address of PV is, and then the value of PV is. Address of P, the value of PV. Now which one should match? These two or these two? These two or these two? Again rerun. So here you can see this. The value of PV is this address. Value of P is this value. This is nothing but the address of V. Value of PV is this one. Value of PV is this one. Okay. Value of PV is this one. This is nothing but the address of V. The address of PV itself is this one. Okay. If you want, I can redraw again for clarity purposes. Value is 10. What is the address? Address is 13631 46620. Remember, we don't have any control over the address. It is up to the system. So this is one. So the value of PV. What is the value of PV? Again this one. Value of PV is 136 314 6620. So these are matching. The address of PV is 136 3146608. So that is the address. Okay, this is how it works. This arrow is shown only for diagrammatic purpose, for understanding purposes. But in system, this is what happens. So the value of V is stored in this location. The value of V is stored in this location. The value of V is stored in this location, and that value is stored here. This address is stored here. So you can directly access this value using V, or indirectly using star PV. Star PV means the value to which it is pointing. It is pointing to this one. The value here is 10. So 10 can be retrieved. So this is how it works. I hope that was visible because of colors. I had to check the video. Okay. What is the next program? What is the next program which we are going to do? Size will be determined, and I hope you understood this concept. Now probably we'll use double one. What is that double one? If I am not confusing. So what is this? Double indirection. What is that double indirection? So if you use double indirection, PVB equal to and of PV. You can store like this. Now printf. Let us see what is printed. %D. I don't write the explanation statement. I will just directly print. So I will use %U to avoid confusion. %U. So V star PV star PVB. Let us see what is printed. You can see 10, 10, 10. All are same. What does it mean? This contains the address of V. What this contains? This contains address of PV. So if you want to reach this location, you have to use double indirection operator. That means one indirection takes it to PV. That means the address that is present, the address of V is retrieved. So if you use another indirection, again star, so the value at this V is retrieved. So this is double indirection. I think that's enough for you. We can play with these things, but again it leads to confusion. Up to this point it's okay. So V equal to 10, PV equal to unV. So we don't deal with this one. Only maybe if you go to the competitive exams, you have to go deep. See, for competitive exams, the orientation itself is different. Please note that. You have to study in a different manner. Orientation itself is different. Understanding the concepts, writing the university exams, it's different from writing the competitive exams. I think I already informed. This NPTEL has started a GATE website where they are placing the videos related to different subjects. If you are interested in GATE, if you want to do MTech, Then start from now onwards. Start from now onwards. Go to that one and try to find out the different subjects, videos related to different subjects, exercise, maybe solved question papers, etc. All will be made available. It started some 20 days back, so they will be available. Okay, this we discussed, and what else we have to discuss? Maybe we'll discuss about these operations. We'll discuss about the operations that can be performed. Operations that can be performed. Operations that can be performed. What are the operations? You can perform incrementation, decrementation. You can add integers. You can add integers. Okay. You can add an integer value. You can add an integer value, but you cannot add 2 pointers. You cannot multiply 2 pointers. That we will see. That we will see. Okay. Let me keep it clean. Okay. Now V is 10. So what we can do? What we can do? So what operations you can do? Operations on pointers. You can perform addition. We can perform addition. So star, let us call it as PV2. Okay, there are 2 pointers. There are 2 pointers. Let me keep it like that. So that is not necessary for this program. Okay, integer star P1, integer star PV2, they are the 2 pointers. What you can do? Can you do the addition? Can you do the addition? Addition of 2 pointers. Addition of 2 pointers. Is it permitted? So incrementation, what are there? What are the operations that we can perform? Let us check it. Let me go back. Let me try one by one. Incrementation of pointers, decrementation, subtracting, addition of integer, they are permitted. Okay. So incrementation, pointer value equal to percentage u, pointer value after incrementation, percentage u after, okay, pointer value, say PV1. So remember we are doing it on the pointers themselves, not on the values to which it is pointing. So say PV1 plus 1, we have incremented. Let us check whether it is permitted or not. Minor variations may come. Compilation failed. Why compilation failed? What is the mistake we have done? Error. PV1 undeclared. PV1 we have declared it. PV undeclared probably. What is this one? PV1 undeclared. Do you mean PV2? Okay. Here I have forgotten this comma. Again compilation failed. Compilation failed. Why? Error. Expected identifier or flower brackets. Which line? Here it should be not comma. They're not bigger. So declaring them separately, we can remove that int and separate them by commas. Okay. Pointer value, pointer after incrementation. You can see here what is the value. Last two digits. You consider only last two digits. It is 60. Pointer after incrementation. Pointer after incrementation is 64. So, but you are incrementing by only 1. What does it mean? See here, you are making it point to integer, or you are declaring it as an integer pointer. You are declaring it as an integer pointer. So, the pointer initially points to starting address, that is 60. So, that means the value, because it is integer, is stored in 4 bytes, not 1 byte. 60, 61, 62, 63. Okay, that makes an integer. Now, if you just increment, it is not pointing to 61, but it is pointing to 64. That means depending on the data type, the value is incremented automatically. That means it is made to point to the next integer, not next byte. It is made to point to the next integer. Okay. So, next, let me copy it. So, pointer value, pointer after decrementation. Let us try to decrement. Decrementation. After decrementation, PV and PV minus 1. Or otherwise we will write minus minus. We will see whether it is permitted. Pointer after incrementation. No, why pointer 72, 76, that's okay. 68, why it is not decrementing pre-decrement? Let us instead write only PV minus 1 to avoid confusion. So PV1. So here we are modifying it. So we'll consider PV2 because we are in this statement we are modifying to avoid confusion. We'll consider whether it is decrementing or not. We will consider PV2. We'll consider PV2. PV2, not PV1, PV2, and maybe we have to initialize it. Okay, some say u, some u equal to some 20. Let us say PV2 equal to and of u. Let us try now. So here you can see incrementation 20 is there, 20 it has become 24. So decrementation, it was 16 and now it has become 12. Decrementation it has become 12. Okay, that is pointer decrementation. And incrementation, decrementation we are able to do. What else we can do? Subtraction we can do. What else we can do? Subtraction we can do. Okay, subtracting two pointers, adding an integer. Adding an integer is same as this incrementation actually. So, but you can add some value. Incrementation means just plus plus. Decrementation means minus minus. So only by 1, adding or subtracting, but you can add some other value. Let us see. Let us first consider what is happening. Okay. Let us try to subtract 2 pointers. Printf subtraction of 2 pointers. Let us try it. What happens? Percentage u let us make it pv1 minus pv2. Now what happens? Build, execute. Subtraction of 2 pointers is 1. Okay, pointer value. So it is, if it is say pointer value 28, 24, it is 1. Why? 28 is there, 24 is there. 28 minus 24, it should be 4. So what is happening? But it is printing as 1. What is happening? So what is happening is they are subtracted, addresses are subtracted, and depending on the data type, it is divided. That is 28 minus 24, that is 4. 4 by integer size is 4. 4 by 4, that is 1. Okay. This may be a surprise to you, but this is how it works. You have to remember. That's all. You cannot change it. Subtraction of 2 pointers. Next, let us add some value, say some 10. Printf subtraction, the adding some integer value, adding integer, say percentage u. So what we do, pv1 minus we are adding integer, so let us add 10. So what happens? So pv1 is 8. If it is 8, now if you add 10, what is happening? You can check. It has become 48. 10 is not added. That means again the same one, similar to the subtraction of 2 pointers. It is incrementing by 10, but it is incrementing by 10 such data types. So integer is 4 bytes. So 10 into 4, that is 40. It is incrementing by 40. That's why it is 48. So remember, it is not confusing. It is actually a very good one for you as a programmer. Otherwise, depending on the data type, you have to change your programs. Now, independent of the data type, so you can increment and decrement. So it is up to the system to find the data type and multiply it and give the correct values. Okay. So it is a beauty. But their subtraction of integer is not given. Let me try it. What happens? Printf subtracting integer percentage u. So pv1 minus 10, let us say minus 10. Is it permitted or not? So it is not in the list. It is not in the list of permitted values. So adding integer, what is PV1? It is 372. 372. So 10 is added, that is 40 is added, it is 412. Okay. That the increment, but 372 you are decrementing. Decrementing by 10 means 10 into 4, 10 into 4, that is 40. 72 minus 40, what is it? 32. Fine, it is working. You can add an integer, you can subtract an integer also. Here to this list which we have discussed, you can add subtracting an integer from pointer. You can add to that list. So these are the operations that are permitted. So though we don't perform these operations only for checking these things, but when you work with what are called as linked lists, stacks, queues, etc., you will do this type of operations, incrementation, decrementation, etc. This will be useful then. Now, what are the operations that are not permitted? Multiplication. Let us check. Printf multiplication of pointer. What happens? %u /n. So PV1, say star 10. Let us do it, whether it is permitted or not. Will it result in error message or some garbage value? So error, invalid operands to binary star. So that means you cannot multiply. You can add, you can subtract an integer, you can do incrementation, you can subtract two pointers, multiplication of integer to pointer. It is not permitted. Okay, it is not permitted. So all these operations are not permitted. So next we'll try addition of two pointers, not adding integer. Printf addition of two pointers. Two pointers is %u PV1 plus PV2. Now is it permitted? No. It is not permitted. Invalid operands. Integer star, that is two pointers. So it is not permitted. So like that, different operations are not permitted. Okay, different operations are not permitted. Okay, I am not going to discuss the other things. You can try it out. So this incrementation, decrementation, generally we do. So check them. How you are writing? Just PV1 plus 1. If you want to assign PV1 equal to PV1 plus 1. But if you just want to move, actually we will be writing only PV1 equal to PV1 plus 1 or plus of PV1. So this is regarding the programming part. We will discuss pointers along with the functions, arrays, and arrays, and also this maybe if possible linked lists in the last module. We'll try it later. Okay, we'll stop here.